Here's the second review video, all about motion. And one of the first things you need to know about motion is a frame of reference. And from that frame of reference, we can measure two things: distance and displacement. Often they're interchangeable, especially if we're just talking about going in one direction. But the difference is, distance is the total that an object moves, and displacement is how far it is compared to where it started. So if we use the example of, here's a 20-meter court, and you've got this person running down through this basket here. I apologize if this is a little choppy. Mr. Johnson just interrupted me. So let's say that this person is running down this basketball court here, okay? And let's say they run all the way down, and then they come all the way back, right to where they started. So their distance would be 40 meters, because they went all the way down 20 meters, all the way back 20 meters. Their displacement would then be 0, because they're right back where they started. Okay? If they went down back again, okay, so they went down back and forth a total of 3 times. Now their distance becomes 60 meters, and their displacement would then be 20 meters, because they're 20 meters away from where they started. So assuming that we timed this individual running down the court, we could then figure out their speed and their velocity. Speed is the distance over the time. So they went, let's say it took them 5 seconds. Wow, that's pretty fast. Let's say it took them 10 seconds. Okay, so they did a total distance of 60 meters in 10 seconds, giving them a speed of 6 meters per second. Velocity would be displacement over time. So if they went back and forth 3 times, the total displacement was 20 meters in 10 seconds, giving them a velocity of 2 meters per second. So there is a difference between speed and velocity. Most of the time, we're talking about just a unidirectional thing, but sometimes they will ask a question about displacement, and sometimes it'll be a matter of they go, let's say, 5 meters north, and then 2 meters to the east, and then south another 1 meter. Okay, and you actually have to figure out what that displacement is. So there are some trickier ways to do this as well, trickier ways for them to ask these types of questions. Now, once we've gotten our speed and our acceleration, those are all for constant speeds or constant accelerations, constant velocities, constant speeds, or even averages. But if that velocity or speed is changing, now we've got acceleration. Okay? And acceleration is the change in the velocity over the time. It's positive if it's speeding up, and of course it's negative if it's slowing down. Now that's on a horizontal plane. If we're talking about a vertical plane, negative is just downward, positive would be upward. Okay? No speeding down or speeding up, slowing down. It's all just a matter of directional for positive and negatives. Now, when we talk about visualizing motion, there's a couple different ways we can do it. We can do it with graphs, but we can also do it with motion maps. It's been a while since we've talked about motion maps. And if you remember, they primarily dealt, as an example, with a car dripping oil every second. So if we have a motion map that looks like something like this, where they're pretty evenly spaced, then we can tell that car, minus that last one there, is going at a constant speed. Okay? Because the amount of distance that it's covering every second remains pretty much the same, and speed is just distance over time. Now if it looks something like this, where they start out kind of close together, and they start to get further and further apart as we go, make those a little bit darker so you can see them here. okay, and they get a little bit further and further apart, then that would be acceleration. And sometimes you'll see one like this, where they start out further apart, and they start to come a little bit closer together. Okay, if that's the case, that's going to be deceleration. And there's all sorts of variations you can have in there. You can have something speeding up and then slowing down, or traveling at a constant speed and then accelerating, or traveling at a constant speed and then slowing down. But these are the basics of the motion maps that you would see. Now, another way to visualize this is with graphs. And typically, there are three graphs that we're going to look at. We're going to look at displacement versus time, velocity versus time, and then acceleration versus time. Okay? Now, there's just a couple different types of graphs that you would see. Something like this would mean that the object is not moving. Okay? Its displacement is staying constant, its distance is staying constant, it's not going anywhere. If that's the case, then that means that our let me just change the size on this real quick. That means that our velocity would be 0. Okay, because the object's not moving, which means our acceleration would be 0. Now, if you see something like this, okay, that means that our distance is changing at a directly proportional rate, or a constant rate. And you can look at the slope. And the slope tells us the velocity time graph. So this slope, oops, let's not call it that, let's just call it slope. Okay? The slope here is positive and constant. That means that our velocity should be positive and constant, like such. Now the slope of our velocity time graph tells us the acceleration. So the slope of a straight line is 0. That means our acceleration.
Mr. Stearns, please report to Mr. Mansfield's office. Mr. Stearns to Mr. Mansfield's office, please.
Oops, sorry about that. And then we go back through here. Get rid of those. Another thing you might see would be something like this, okay, where the displacement is decreasing over time at a constant rate. So in this case, the slope is negative, and it's still constant. Yeah, there's an S in constant. Fix that. Okay. So that means our velocity would be negative and constant. So that would be below the 0 line. Now because this is a straight line, our slope of this is 0. That means our acceleration is going to be 0. Okay. So let's go to something that has an acceleration. If we see a graph like this, so our displacement is increasing exponentially. So the slope for this one is still positive, but remember that the slope is just a series of tangent lines. So it starts out fairly small and it gets bigger and bigger and bigger, so it's increasing. That means that our velocity is increasing, and it's positive. So positive line, increasing. Okay. Now, we're never going to see anything other than either a flat horizontal line or a diagonal line for velocity time graph. The slope of this velocity time graph is positive. Okay. So because that ends positive and constant, because it's positive and constant, that means our acceleration time graph would be positive and constant as well. Let's do one more different variation you could have here. It'd be something like this. Okay, the displacement is decreasing at a varying rate. So in this case, okay, our slope is changing, and it's actually going smaller. Okay, so it's decreasing. Did I spell that right? Yeah. Okay, it's decreasing, and then in terms of being positive or negative, in this case it's negative, decreasing. So we would see something like this. Oops. Okay. And now that makes this a negative constant line, which makes our acceleration that. Okay. If you have any questions about that stuff, feel free to see me about the graphs. We'll do one more thing here. Basic kinematics equations. Okay. Basic equations are average velocity is displacement over time. Okay. VF equals VI plus AT. VF squared equals VI squared plus 2AD. And D equals VIT plus 1/2 AT squared. Now these are all in your reference tables. Okay. The average velocity is your total displacement divided by your total time. Now VF is your final velocity, VI is your initial velocity, and AT, this is the acceleration, and this is obviously the time. That doesn't work very well. Let me try something else. Okay, there we go. So VF, if it's coming to rest, okay, so it's slowing down to a stop. If it's stopping, VF would be 0. If it's starting from rest, that means our initial velocity is 0. They might not come right out and say that the initial velocity is 0, but take that into account. Make sure you read the question, and because that might be something that they're telling you, not necessarily outright, but they're giving you clues to it in the question. For the last equation here, that d is the distance or the displacement, and then I did leave off a squared here. Okay, AT squared. And don't forget to square that time. That happens a lot. All right. We'll talk more about these in the projectile video, and I'll show you some examples on how to use this. These can be used for either straight line motion, or they can be used for projectiles as well. Okay. That's it for this video.